Okay, this is an example that will help you understand working in base 5. Now our system works in base 10, so we use 10 different digits, 0 through 9. So it should make sense in base 5 we use digits just 0 up through 4. Because it's in base 5, and by the way, you can tell that a number's in base 5 really only because the base is written in a small font, usually just down and to the right of the number. So because we know this number is written in base 5, we know that this first place value is the ones place, just like it is in all our other bases. But now instead of going by tens, the next place up is going to be 5 to the first power, or just 5. The next place is going to be 5 to the second power, or 25. The next place would be 5 to the third power, or 125. By the way, this very first place, you could view it as 5 to the 0 power, which is 1. So if I want to figure out what number I've got here in base 10, all I have to do is take each one of these values and multiply by what it represents. So I'm going to take 3 times 1, and 2 times 5, 2 times 5 squared, and 2 times 5 squared, and 1 times 5 cubed. So you can see I've done the arithmetic here. I've taken 1 times 5 cubed, or 1 times 125 is 125. 2 times 25 is 50. 2 times 5 to the first is 10. And then finally 3 times 1 is 3. So if I add those up, I get 188. So the number 1223 base 5 is the same as the number 188 in base 10. By the way, you don't have to write the base when you're in base 10. It's assumed to be base 10. But I'll go ahead and make a note of it there. You might wonder why we work in a base like 5. Future teachers especially, it's really helpful because when you're working in other number bases other than base 10, it really causes you to go back and think about problems that students might have when they're first learning base 10. So in base 10, of course, you're grouping by tens, and in base 5, we're forcing you to think about grouping by fives. So it kind of takes you back into their world and makes you think about how younger students just learning their base 10 system might be struggling with some concepts and how you might best help them. Okay, so now the next thing I want to do is try to figure out if I have a number in base 10, how would I convert it to base 5? So the example I've chosen here is 702 in base 10. I want to write that in base 5. So what I think is really helpful is write down these different bases. Put the bases down so that you've got them to refer to. So again, we've got the ones place, the fives place, the 5 squareds, which is 25, the 5 cubes, 125. And then I went out one more place. 5 to the fourth power is 625 because the number I'm dealing with is 702. So the first thing I notice is that I definitely need one of the 625s because 625 will go into 702 one time. So I know right away that I'm going to need one of the 625's place. So what I'll do next is subtract that 625 because what I want to know is how many do I have left over. So let's see, 702 minus 625 is 77 left over. Okay, so now I move down to my next place, which is 125, and it's I'm thinking, wow, I only got 77 left. I don't need any of the 125s, so I would put a 0 in that place. Okay. Moving down to the next level, how many times will 25 go into 77? And you can see that it will go 3 times, so I'm going to need 3 of those. And again, 3 of those, 325s is 75. So I subtract and I end up with 2 left over. So I know that I don't need any 5s because I've only got 2 left over. So I'll fill that in with a 0. And then finally, I need to I need to consider the last two, so this last place would be a 2 then. So the number 700, the number 702 written in base 5 would be 10302 base 5, and I should probably put the label here. Be careful, don't read this number as 10,302. It's not. That would be as if it were in base 10. To read a number in base 5, you simply list the digits, 10302, and then you say base 5.